Good morning. Wednesday morning. The experience working as basically a licensed engineer in disciplines. I held titles, and this is about me, but I held titles and worked within organizations that maintained the licensing for the work that we did. In almost every case, whether somebody else was designing something or I was designing something, it was reviewed. For higher level projects, my financial projections were reviewed. When the project started, the projections were reviewed weekly and monthly for financials, just financials. That's one meeting you tick off. We were Zooming before Zoom was cool. If you remember driving by General Motors manufacturing plants and seeing EDS satellites up on the roofs, EDS satellite data systems, well, that's a hint. We've been doing this stuff a long time. It's better. It's newer, but it's not new. So, professional engineering work. This is where you get into the land of peer reviews. Peer reviews, the same processes defined in research sciences, only to a different level, a different audience, a different group. These are engineers putting things together that already exist. The big conversation and things like that is COTS, the acronym COTS, Common Off-the-Shelf Systems. That grows very important when you're trying to maintain a technical base for all the robots and the computers around you. If anyone's aware of how well-paid COBOL programmers are today, that is a byproduct of legacy applications being out there. So, yeah, but this peer review, this review idea is constant and ongoing. Yeah, you might retreat to your office for 3 days or a week, building papers, building the schedules, building the sequence, having conference calls, teleconferences, setting up schedules for multiple sites to do the same thing, travel resources, training resources, DBAs for startup activities, transition and rollout activity plans. So when you do an update on a piece of software and you break a manufacturing system, you have to be able to undo it quickly. So rollback techniques and mechanisms in computer systems and databases. These are the considerations out there in just a piece of the computer world. When my robot cells were being put together and re-engineered and redesigned, I didn't do the safety interlock systems. That work was sent to headquarters for design clarifications, requirements, and basis, and those standards came back out to be implemented in thousands of work cells across the Americas, definitely. What else do you see? After 15 years of working in North American assembly plants on our automation systems, how America automates, where we put robots, how we make the decisions of what robots to put where and why. Hazardous environments are a good reason for robots, excellent reason for robots, keeping people out, minimizing personal contact. Inside of paint booths, excellent place for robots, although it is still very hard to match the capabilities of the human eye and those artists that can paint cars so much better than robots still. So there's a challenge. This is big systems, big processes. These measures on a multi-million-dollar project, I might be auditing 5, 6, 10 different small facets of it, looking for something to point out to a manager or an engineer to say corrections required. You're doing this wrong. We're going to flag your project for process violations because your paperwork's incomplete. And this wasn't small teams. This is a global corporate strategy inherent in all corporations. I could speak to other industries. We're talking about building cars right now across the globe. But this is engineering disciplines, engineering work. Now, somehow, Those things are required. When you see a sticker on something that says ISO 9000 whatever certified, when you see underwriters, laboratories, stamps and stickers, if they are legitimately awarded, that's a good question, they are valid reasons to accept that instrument as what it's sold, how it's sold, what it is, the accuracy of it, the precision of it. These details go into, you could spend years deciding on the correct instrument, the correct techniques, and make an interim decision to get you by until the correct one's there. What you don't do is go placing ignorant counters with spectrometers. You don't go replacing small end devices with massive supercomputers. You don't go putting technology where it can't be maintained and kept up. So what do you see when you go into these plants? All of a sudden, after, like I said, 15 years about of working within North American operations, Canada and America, with very reasoned labor laws. We don't want to hurt people at work. We don't want to kill people at work. We want them, well, we're not sure, but we want them to be able to retire in comfort and enjoy the rest of the whatevers they've earned. We, that mouse in my pocket in these engineering conversations. There is ethics in engineering. There is legal requirements in engineering. At an executive level, things like due diligence are conversations in court and what due diligence means. Who interpreted the rules and regulations from high up and above. That gets into legal challenges. It's the only place you can take people at that level. You can't hold them personally responsible because they're hiding in a corporation structure. They're hiding in the skirts of greater men. Too long. Pieces out.